Dear students, welcome to another lecture in industrial engineering. We were studying the subject, we were studying the chapter about ergonomics. Yesterday we have seen about anthropometry. Okay, continuing with the same topic. Now, in anthropometric data, when we are using for ergonomics, we use something called as percentile. Yesterday I talked a little about this. Okay. Further continuing upon this, for understanding the principles used to apply anthropometric data for designing any machine or control or any physical facility or equipment, the knowledge about percentiles is essential. Now, percentiles are shown in anthropometric tables and they indicate whether the measurement given in the tables relates to the average person or some special person, someone who is above the average, much above the average, or much below the average in any particular dimension. Now, for understanding, let us consider the height of a person. Now, if we look at the heights of a group of people, it is found that most of them have approximately same height. If you are talking about all grown-ups, like adults, okay, or even if you consider your class of students, their heights, there may be some very tall people and very short people also, but mostly they will be of same height. This same height will be near the average or the arithmetic mean of the heights of the people of the entire group, and this average or this mean height is called as is shown as the 50th percentile. Now here you may be knowing about the normal distribution curve. So now normal distribution curve is also used for anthropometric data. Now heights of the people are plotted, and you see how many times, how many, see on the x-axis we plot height, and on the y-axis we plot the number or the frequency of occurrence of people of a certain height. See, suppose 5.5 feet, some 10 people are there, so this center may be 5.5 feet, okay, and some 10 people may be there, so this may be 10. So above 5.5 means 5 feet 6 inches. Say suppose 5 feet 7 inches, less, a little less, instead some 7 people are there, like that. If you further increase the height, it falls like that. And this if you draw a curve on these on this data, you will get a bell-shaped curve, and which is called as normal distribution curve. Normally the arithmetic mean is normally it has the maximum, and as you go towards the ends it will reduce like this. Okay, now see, now mostly people may be average height, but out of the remaining, few may be noticeably taller and few may be noticeably shorter. That means same height is the most likely height in the entire group of people. Okay, this metric can be this this quantity that we are measuring, this dimension that we are measuring, may be anything. See, for example, we are taken as a height of people. It can be weight of people, or it can be the arm length of people, or any such metric, any such a dimension. Okay, see, if we plot, as we have plotted normal distribution curve, we have seen here, and this graph, normal distribution curve, is symmetric. The graph tails off towards the ends, that is, the graph decreases at both sides of the 50th percentile. Now the center one we are calling is 50th percentile, and as you go towards the left, so there is something called, we have put a mark here and we call this as a 5th percentile, and on the right side if you see we have marked another place and we called it as 95th percentile. Okay, see what is the 5th percentile, that also is explained in this graph, it's in this diagram itself. That means 5% of the user population is in this area. 5% of the people fall towards the left. And what is the 95? See, the 95th percentile, 95 people fall to the left, only 5 people fall to the right of this line. Okay, that is 95th percentile. So if we are talking about two extremes, no, you see, 5th percentile means, the shortest of shortest side, and 95th percentile means the tallest side, like that. So that means, above 95 only 5% of the people may be there. Above, below 5th percentile only 5% of the population may be there, like that. Okay, now see, on the left side of the 50th percentile, 5th percentile we seen, and on the right side we have seen the 95th percentile. Therefore it is necessary to know whether we are designing, if you are designing any machine or any equipment or any workstation or any control or anything, if you are designing for the people represented as the 50th percentile, or whether we are designing for people represented by the 5th percentile or 95th percentile, having height below or above the average height respectively. See, first we should know we are designing for whom. Are we designing for the average people, or are we designing for the 5th percentile people, that means the shortest of them all, or are we designing for the 95th percentile of the people? Okay, that means the tallest of all. Okay, so this is nothing but the decision to be taken about how many percentiles of user population is to be accommodated or satisfied with the designed and manufactured physical facility or the equipment or machinery or whatever. Okay, now see why we are studying this, because we are going to use this while designing. See, these are the principles in application of anthropometric data. See, following 3 principles are used to apply anthropometric data for designing any physical facility or equipment. See, first principle is design for extreme individuals. Design for extreme individuals. See, like okay, we will see in detail. Okay, design for extreme means design for maximum population value. See, normally this is the recommended strategy. If it is possible, we have to design so that everybody may be able to use that facility. If given maximum high value of some design feature should accommodate extreme individuals. You see, suppose we are designing a bed. You see, what should be there? It is not the smallest person is not the criteria here. If you are designing a bed, the tallest person is the criteria. If the tallest person can sleep, then the shortest person also can sleep. Okay. But there are certain things, designing for minimum population also. Minimum population value is appropriate in certain cases. If a given minimum value of the design feature has to accommodate all. Here there is an example. You see, distance of control from the operator. Suppose somebody Suppose people, an operator is there. He has to reach his hand and switch off the button or switch on the button. See, now the criteria is it should be as closer as possible so that the smallest person can reach it. You see, now if the smallest person can reach, the tallest person can automatically reach, can naturally reach. So now in that such cases, the tallest person is not the criteria, but the shortest person is the criteria. That means here the fifth percentile we should consider, not the 95th percentile. Whereas in making of bed, we should consider the 95th percentile and not the 5th percentile. Okay. Now next, it is sometimes necessary to design certain aspects of physical facilities so as to accommodate individuals with the relevant anthropometric characteristic at one extreme or the other. You see, that's what we have said. You may have to design a certain thing in of one extreme, like taking fifth percentile, or you may have to design some other facility considering the 95th percentile on the other extreme. Okay, now here an example is there. Now while designing of the doorway, see the door has height and width. Okay, the criteria here, see, like a bed only, this door also. See, the criteria will be to accommodate large number of people, that is 95% of the people. So other people, you see, even what you may say, what about the remaining 5%? Okay, they may have to bend a little, or if it is, I see, there are two dimensions. So people may be taller and people may be fatter, or wider, you can say. Okay, see, the taller people, that's why what will be the doorways height? You see, in India, normally around 7 feet or something they keep. 6.5 feet, some people, and 7 people, some people keep. Okay, seven if you keep, see, in India to find a person above 7 is very difficult. Okay. But there may be such cases, one or two in a population of, see, 1 or 2 lakh people. If you take 1 or 2, you may find who are above 7 feet. For what to do for them, they have to bend a little and go. And similarly, there may be wider people. You see, now our doorways normally are 4 feet wider. Now, suppose if somebody is more than 4 feet, what to do? Then he may have to, somehow squeeze himself or turn sideways and go. Okay, so thus the minimum dimension of physical facility should be based on the upper percentile of the relevant anthropometric characteristic of the population, such as 95th percentile, or you may design even for 99th percentile. That means almost all people can be accommodated. You may design like that. The same door, if it is some big office or something, some collectorate office, those doors will be much taller. Everybody can. Okay, like that. Okay. Now, yeah. Similarly, we can prove that maximum dimension of a physical facility should be based on lower percentile of value of the relevant feature of people, such as 5th percentile or 1st percentile. See, like that. See here, another example on the lower side extreme. See, for doorway and bed, the 95th percentile, you see. But here, when 5th percentile is used for that in example, if you want to decide the location of control device on a machine in such a way that every individual can access it or reach it, you see, at what height this control should be. You see, if you keep for 95th percentile, it will be too high for the short people. Even average, if you keep some too shorter people may not reach. But if it is for the 5th percentile, if you consider, then everybody can reach. Okay. So this has the logical assumption that if individuals having short arms can access, or reach the control device, then individuals having longer arms can also access and reach the control device. Okay. The values corresponding to 95th percentile and 5th percentile are chosen because to accommodate 100% of people would generally, will be maybe very costly. It will be too expensive. A little bit of compromise on the. You see, sometimes when we are traveling the trains, we see some people, those taller people, their legs will be poking out of the berth. But what to do? They'll be uncomfortable through the night. But anyway, they have to manage. You see, for those who, one or two people in the bogie, see the entire train, sizes cannot be increased. It will be too expensive to do it. Okay. That is the first criteria. Not see, we were seeing three principles. The first principle is designed for extreme individuals. In some cases, like doorways, we designed for the 95th percentile people, and for reaching the on-off buttons of a machine or something, for the 5th percentile people we have designed. Okay. Now the second case is designed for adjustable range. You see, instead of making one fixed value, fixed dimension, why don't you allow for adjusting range? Okay, there are certain features of equipment or facilities which should be designed as adjustable to accommodate people of varying sizes. That means design features of equipment such as or physical facilities are such that there should be a provision for adjustment. Okay, for example, automobile seats. Now, if you sit in front of a car, and as in the driver's seat, if you sit, you can pull it a little forward, you can push it a little backward, and even the steering wheel, you will be able to adjust according to according to the driver's convenience. Okay, see, automobile seats, and you may have even the facility of raising and lowering the seats also. Okay, automobile seats, desk heights, chair heights for telephone operators, computer operators, typists, etc. These are certain examples where adjustable range can be provided. Okay, in design, it is common practice to provide for adjustment to cover the range. You see, now how much adjustment we will provide, so that it will cover 5th percentile people and 5th percentile female, because normally females are made shorter, and males are made taller. So that's what we see generally in the population. So the 5th percentile female means that is the shortest. 95th percentile male means that is that is the tallest. Okay, so this shortest and tallest, these in this range, if you can provide the adjustment, then that is the best. Okay, then the amount of adjustment or the cost of providing such an adjustment requires to accommodate the extreme cases. That's what 95th percentile to 5th percentile, 95th percentile male to 5th percentile female. Okay, then okay, see, what they are saying is the amount of adjustment or the cost of providing such adjustment required to accommodate the extreme cases, such as people above 95th percentile and people below 95th percentile, is disproportionate to the additional number of persons who would be accommodated. This point can be illustrated by adjustability requirements of the chair seats. Is additionally some other adjustments of the chair seats you can provide, but the cost may be too high to accommodate this. That's why some discomfort will be there. Now here you see a figure, a plot of cumulative percentiles of people against their seating height. You see, on the x-axis you have percentage of people, and on the y-axis you have the seating height. Now you see, you have plotted um, plotted this curve, and you have got some curve like this. No, this is looking more like our creep curve in design. Okay, anyway, see, now here you see it has started on the y-axis at 75 centimeters, and you see our fifth percentile is at 85 centimeters, and our 95th percentile is 95 centimeters, and 99th percentile is 97 percentile, and 100 percentile is 102.5 centimeters, like that. See, here you can see this is the first percentile, this is the 95th percentile, this is 5th percentile, and 95 percentile. This is the bottom range, where 96.5, and the top range 102.5. that means top range means all the 100% people are below this, bottom range means all the 100% people are above this. Okay, like that. See, it is easy to note that the seat adjustability requirement, you see, if you see here, if you see from the 5th percentile to 95th percentile, 5th percentile is starting at 85 and 95th percentile is ending at 95. See how many centimeters difference is there? Only 10 centimeters here. Can you see? If you are considering 95th percentile and 95th percentile. Suppose if you consider first percentile and 99th percentile, here it is 87, here it is 82, and there it is 97, and this difference is how many? 15 centimeters. See, in the first point, just in 90 centimeters you will be able to cover 5th percentile to 95th percentile. But if you go to 15 centimeters, you will be able to accommodate from 1st percentile to 95th percentile, 99th percentile. Okay, but if you want to cover the total range, then for the total range, it is 102.5 to 76.5. This is 26 centimeters. You see, from 15, 11 centimeters you have to increase just to accommodate those extreme cases. We don't know whether they will be present or not in our population. Okay, see, so because of this, therefore the differences in seat adjustment requirements are disproportionate at the extremes to the additional percentiles which would be accommodated. See, that means it will be involved with much expense. Okay. Now the third one. Now we have seen two already. The first one is designed for extreme individuals, like doorway and reaching of the knobs of any machine. The second is designing for adjustable range, like this revolving chairs or automobile seats and such things. You provide a range, but in the range, you provide such range so that from 5th percentile of female to 95th percentile of male, everybody can be accommodated. Okay, next we will see the third one. Third is designing for the average or the average person. Just design for the average and leave it. You see, there is an average individual, and a person may be average on one or two body dimensions. Designers often design for average as a compromise. This is a compromise, just to design and keep. See, because they do not want to deal with the anthropometric data. If they are lazy, if they don't want to go into anthropometric data, one thing, or if they don't want to spend so much money, they want something cheap. See, then no, they won't be considering anthropometric data. Just make some average thing and leave. Okay. Some of the designers may claim that such and such equipment or facility has been designed for an average man. See, but in the domain of human anthropometry, there are extremely few persons who would really qualify as average or average in every respect, for that matter. Okay, so the concept of average man is just a myth. A myth means, it's not a real story, it's a concocted story. That means, in the whole world, average in every respect to find somebody is very difficult. Okay. However, the design of certain physical facilities where it is not appropriate to use the extreme values, that means minimum, maximum, that that fifth percentile and 95th percentile, to use that, it is not feasible to provide that. It is not feasible, and also it is not feasible to provide the adjustable range. That means the earlier two conditions are not possible. Then the use of average value is preferred. Average value is preferred only in those cases when those extremes cannot be given, extreme values cannot be made, or you cannot provide the adjusting range. Okay, here is an example. Now, where this criteria can be used. Now, suppose that you have a water cooler. On the water cooler, you have to provide a tap. You see, there is no, you cannot provide very low or very high. Okay. And you cannot provide any adjusting range also for the tap. So what will you do in that case? For an average person, you provide it. You see, it will be less comfortable for some people. Okay, because we have not designed it for the extreme people. This does not indicate that it would be optimum for all people. Rather, it indicates that collectively it would cause less difficulty and inconvenience for those people who are in the extremes. Extremes means on the lower side as well as upper side. Okay. So now you have got this idea. The first case, remember bed or doorway, and for the smaller, shorter side, you can the control of machine. The second thing, adjusting range, is like automobile seats or the chairs of revolving chairs and other things. Okay, and the third case is the taps, water taps of the water cooler on a water cooler. Okay, so these are the three things. Okay, now next coming to the next topic, ergonomic considerations while designing a machine are three aspects of man-machine system. What considerations? What are the ergonomic considerations? We have to incorporate. Okay, three aspects of man-machine system means these three that we have seen. Okay, major ergonomic consideration in the process of designing of machines are these. The first one is design of controls. You see, now we are dealing with the machines and other things. When a man is operating a machine, he has to operate the controls. Those are the controls we are talking about. The second thing is there will be some displays, information giving displays. Okay, so we have to design the information displays. And the third one is the environmental factors, dealing with the environment as well as safety. Now, control members or controls you call, or devices you call, or equipment used in machines. Now, controls means devices. Controls are devices through which man conveys instructions to the machine. See, on a motorcycle you are going, you want to go faster. What will you do? You raise the accelerator. Okay. If you raise the accelerator, that means you are conveying, means you are telling the machine to go faster. When you reduce it, you are saying, Okay, so when you're reducing, what you're saying is you go slower. Okay, that's what you're saying. So through the controls, you are telling you're talking with the machine. You're conveying some instructions to the machine. In other words, a control device is used to transmit information to some mechanism or to some system, uh, or something like a machine or equipment or whatever. Okay, controls provide a method for workers to change the status. Whatever status is there, to change the status, the workers need some controls, and to change the operations of a machine. Till now you have done this, now you should do this. The operator will press some control or use some control. Okay, now let us see about the different types of controls that we use. Is it depending upon the nature and type of information desired to be transmitted, different types of control devices are used. They are available which perform the functions. Now in this table we have this table goes to the next slide also. So there are 7 different types of controls. The first one is hand control. Hand control, with the hand you operate, quick to operate hands. All who are driving cycles or motorcycles, in the hands you have controls. You have controls in the hands. Accelerator is in the hand, front brake is in the hand, and your clutch is in the hand. All these are in the hands. Your headlamp, horn, all these controls are in the hand. Okay, hand levers they give quick response, also quick control action, quick, because with the hands we can operate fast. But we may not be so quick in operating with our legs. Okay, because hands are more sensitive, legs are not so sensitive. Okay, so hand levers give a quick control action and can accommodate large forces also. They are suitable for on off. You can put on or off, or step up or down. Stepped up means you're like accelerator, stepping up the accelerator, stepping down the accelerator. Such kind of operations, they're not suitable for fine adjustments. Very fine adjustments you cannot do with the hand lever. Now second control device is hand wheel. Now hand wheels are used for precise activity involving large angles of rotation, like your steering wheel in the car is a hand wheel. You have hand wheels in the lathe machine also. Hand wheels are there. You can provide good accuracy of adjustments in lathe machine. Even graduations are given, fine graduations, accordingly you can give. Okay, they provide controlling torque via both hands. You can use both hands also, and they are used for heavy loads. Special design requirement is there should not be chances of slipping. Slip should not happen in hand wheels. If you are driving in the car, steering wheel, you suddenly if it slips, what happens? Accident will take place. Such things should not happen. So that is a special requirement, design requirement. Slipping is not allowed in hand wheels. Okay, then foot pedals. Foot pedal is the another control. Foot pedal, in the cars you have foot pedal. In the bikes also, in motorcycles you have the back brakes you apply on the lever with the foot. Okay, foot pedals are used for fast action control with medium or heavy loading capacity. They lack in accuracy and range, which may be obtained with hand control. Hand controls, you can more accurately manage, and accuracy as well as range also is less for the foot controls, foot pedals. They are used in sitting position normally, but there are certain cases where standing also they provide foot pedals, especially operating some machines. Okay. Now the fourth control is crank. You see, there are certain figures here. If I can show you, see, crank is like this. You see, if you rotate, crank is like this. Hand wheels are like this. Okay. Okay. Now, cranks are used when rotation through more than 360 degrees is needed. Now hand wheel will not provide more than 360 degree. More 360 degree means what? One full rotation. More than one full rotation, if you need, you have to use crank. You cannot use hand wheel. They are intended to provide torque via one hand. Yeah, whereas here, no, this with two hands you can operate, but this with only one hand. Okay. See, hand wheels you can operate with two hands, whereas crank you will operate with one hand. Smaller cranks are used for fast control. Special design requirement is grip handle should turn freely on the shaft. You see, if you are using crank, you see, on the crank you should provide a grip, and the grip should not be rotating in your hand. The grip should rotate freely on the crank. Okay. Yeah, where we are. Okay. See, now next control is knobs. Knob. You see in the figure here, knobs. Okay, knobs. Size of knobs depends mainly on the resistance to motion. How much resistance it provides. Generally, circular shape is used for knobs. Rotating knobs are recommended for light loading control with either fingers or the whole hand. Some are small, so with the fingers you operate. Some are larger. You may have to use the whole hand, with one hand. A little bigger knobs. Okay, use of knobs is generally preferred in applications having continuous variables. If variables are continuous, then these knobs are preferred. Knobs are also used in instrument control panels. In instrument control panels also you can use this. Okay, knobs. Then next control control device is push buttons. Push buttons means, you see here, the push button. Here the push button is. You press once, it is pressed, and I can press again, it is released, like that. So these push buttons are normally designed for operation by one finger. With one finger you will push buttons. They are essentially used as a light load on off controls, on off, like our light switches and fan switches and all. Okay. See, our regulator of the fan is knob, whereas our on-off buttons, doorbells and such things, no, they are push buttons. Actually, these buttons, no, doorbell only is push button. These on-off button, no, for light and fan, what off buttons are there? Those are toggle switches. They are called. Okay. See, the push buttons are rather better compared to those things. Okay, special design requirements is that for the push buttons there should not be chances of slipping of finger or accidental activation. Sometimes by a mistake also the button gets pushed, and because of that, what happens, because of that, some accident may take place. Okay, then joysticks. This is a type of hand control which is nowadays extensively used in computer games and mobile, internet games and such things, and applications on CNC machines also. Okay, such things, joysticks are used. That is the seventh control. So in this figure we can see the types of controls: crank, hand wheel, knob, and horizontal lever. It can be operated up, down like this. and then push buttons and foot pedal are given here. uh, okay, I think today we'll stop here. We will continue again in the next lecture. Thank you very much.